Bismillahirrahmanirrahim and Assalamu alaikum. Today we will have to start the laws related to gases. In this topic we will have to learn about various laws, the Boyle's law, Charles' law, etc. First of all, what are gas laws? The behavior of gases towards pressure, temperature and molar amount is governed by the following laws. It means that these are the relationship of volume with temperature, pressure and molar amount of a substance, of a gas. So first of all, let me start the Boyle's law, which was presented by Boyle in 1662. This is the relationship between volume and pressure, but we have to keep temperature and number of moles of a gas constant. The law means that if we take equal amount of a gas by keeping the temperature constant, then what will happen to volume by changing the pressure? So Boyle says that the volume of a given mass of a gas is inversely proportional to pressure at constant temperature. It means that if we take a fixed amount of a gas and if the temperature is kept constant, then by increasing the pressure the volume will decrease, or by decreasing the pressure the volume will increase. So there is an inverse relationship between the volume of a gas with the pressure. So to convert proportionality to equality, V is equal to K divided by P, or PV is equal to K, where K is called Boyle's law constant. This equation gives another definition to Boyle's law. The product of pressure and volume at constant temperature and fixed amount of a gas is always remain constant. So Boyle's law can also be defined as the product of pressure and volume of a fixed mass of a gas is constant at constant temperature. If the temperature and amount of a substance remain constant, then the product of PV will always remain constant. Let me prove it through a very simple experiment. A certain mass of a gas is enclosed in the cylinder at a particular temperature. Let's say the pressure of the gas is P1, having a weight represented by an arrow. The volume of the gas is 1 decimeter cube. At the same temperature, when the pressure is doubled by doubling the weight over the piston, then the volume remains half. If the pressure increases 3 times, then the volume remains 1/3 of the original volume by keeping temperature constant. So in all these experiments, the temperature and amount of the gas remain constant. Now when we increase the pressure, the volume correspondingly decreases. Now we have to prove it mathematically that whether the product of PV remain constant at constant temperature or not. The data obtained from the experiment, when the pressure was 1 atm, then the initial volume was 1 decimeter cube. Now put the values in Boyle's law equation. P1 V1 is equal to K, or K is equal to P1. The value of P1 is 1 atm, volume 1 decimeter cube, so the constant value is 1 atm dm cube. Now when the pressure is doubled, it doubled from 1 atm to 2 atm, the volume remained half of the original volume. The original volume was 1 decimeter cube, but now the volume remained half. Now putting the values in Boyle's equation, so P2 2 atm, V2 half into 1 over 2 of half into 1 decimeter cube. So multiplying the value, the value of K come out to 1 atm dm cube. Now in the third experiment, when the pressure was increased 3 times, then the volume remained one-third of the original volume. Again, PV is equal to 1 atm dm cube. Now, if you look at all the values of K, it is same. It means that K1 is equal to K2 is equal to K3. So P1 V1 is equal to P2 V2 and it is equal to P3 V3 and it is equal to constant. It means that the product of pressure and volume remain constant if temperature and number of moles kept constant. The graphical representation of the Boyle's law. If we take pressure on x-axis and volume on y-axis, then a falling curve is obtained, which is called the isotherm. It is called isotherm. Iso means same, therm means temperature. So in Boyle's law, the temperature remains constant. That is why the curve is said to be the isotherm. This curve is obtained at constant temperature. That is why it is called the isotherm. Now, if you look to the graph carefully, when the pressure was low, then the volume was high. Look at this. When the pressure, let's say this is the pressure, then the volume of the gas was high. By increasing the pressure, now the pressure is increased to some extent, then look at this, the volume decreases to remain. Similarly, when the pressure is further increases, then look at this, the volume further decreases. So increasing pressure will decrease the volume and a curve is obtained which is called the isotherm. In this area, there is no net change take place further. It is because the gas molecule comes so closer to one another that increase in pressure do not change the volume. So after this, the line become parallel to the pressure axis. Now if we look at this figure, when the pressure was very high, look at this, the pressure is written very, P is written very big, then the volume was small. When pressure decreases, volume gradually increases. When pressure is further reduced, the volume is further increased. And when pressure is very less, then the volume is very inversely. If we say from top to bottom, when the pressure was low, like in this graph, then the volume was very high, like here in this graph. When the pressure is increased, then volume decreases. When pressure is further increases, the volume further decreases. When pressure is increased more, then the volume further decreases. So a curve is obtained which is said to be an isotherm. This graph also shows the inverse relationship between the given amount of a gas between pressure and volume of the given amount of a gas at constant temperature. How to solve a problem by taking Boyle's law under consideration. Remember that whenever you are solving a question, first of all you have to write the given data, then you will have to apply the formula, and after it you have to put the value with their units in the formula, and at the end the answer along with the unit. So look at the question. A 530 decimeter cube of a sample of hydrogen gas was collected to a container at 800 mmHg of pressure at room temperature. What volume will the gas occupy at 400 mmHg? So if you look at the question, the volume is given. It is V1 530 decimeter cube. Similarly, the pressure P1 is 800 mmHg. Look at this, the temperature is room temperature, so it remains constant. We have to calculate what is the volume V2, and P2 is given is 400 mmHg. So first of all you have to write the data, then We know that P1 V1 is equal to P2 V2. We are going to calculate V2, then P1 V1 divided by P2, putting the value with their units, so we will get the answer along with its unit. So it is all about the Boyle's law. Inshallah, we will discuss the next law, the Charles law, in the next lecture. Thank you and have a nice day.